It's all right now, yeah.
And it went back again. Yes, ma'am, it's perfect now.
Okay.
Shall we start?
Yeah.
Okay, once again, I welcome Mineeshma Jia from CDAC for a technical session. Welcome, ma'am.
Okay. Thank you, Renu. A very good morning, one and all. Myself, Mineeshma from CDAC Trivandrum. And actually, the CDAC Trivandrum, you all know, Center for Development of Advanced Computing. We are a scientific society of the Ministry of Electronics and Communications Technology of Government of India. We are carrying out various technology developments in electronics and information technology and the associated areas. CDAC headquarters at Pune, and we are having 14 R&D labs in all over the country. We are working in various industrial collaborations, academic collaborations, and all, working with industries and academics for the development of various technologies under various ministries. And Power Electronics group of CDAC Trivandrum now into development of various technology developments. And actually, we undertake application oriented R&D in electronics. We promote growth in industries by working in those in close cooperation with the industries, and design, development, deployment of electronics and advanced information technology products and solutions. We are currently working on EV charging solutions in association with various OEMs and various industries, various academics in the country. Today my agenda is having a lecture on EV charging infrastructure and its standards. Actually, transition towards electric mobility is happening all over the world. Government of India sets ambitious target that within 2020 the electric transport in our country, the transportation would be through only electric mode. That is an ambitious target, and that obviously it cannot be fulfilled due to various hindrances. And in view of that, some policy or some mission is started by the government, and it's known as National Mission on Electric Mobility. The mission is cannot accomplish its NMM 2020, and we cannot accomplish completely accomplish that EV adoption in the country. So further to that NMEM mission, Government of India formulated some more missions that were policies or regulations associated with EVs, EV charging, EV adoption. The mission named mission targets to adopt the or accelerate the EV penetration to the existing EV traffic of in India. So in that, the FAME, that is faster adoption of manufacturing of EV and hybrid electric vehicle, that is FAME 1, which is started on later 2015, and now it's running FAME 2, where the continuation of FAME 1 is happening. The FAME 1 targets to set more charging stations. The main hindrance to EV adoption or EV penetration or EV electric mobility acceleration is identified as the lack of charging infrastructure. Is the main hindrance to EV adoption. Hence, we are the government is planning or plan to set more and more charging stations or EV supply equipments and such things in the country, and then charging infrastructure. Further to NMEM, FAME 1 and FAME 2 is formulated, and FAME 2 is now running, and its main aim is to main aim is to adopt the EV, more and more EVs, more and more public transport has to be electric. The main aim of the FAME 2 is the faster adoption of electric vehicle in the public transport. So the policy regulations are stakeholders are coming out, or many OEMs are coming out with EV charging infrastructure, and many technologies, but indigenously developed technologies are less available in our country. That should become for the exact development of that actual development of our EV charging infrastructure. So then comes the standards. Standardization also need for the interoperability, or actually there is a lot of various vehicle segment is there in our country. That is light electric vehicles, passenger vehicles, like that. So the standardization should be done for the interoperable nature of EV charging. So I will be briefly describe about the EV charging infrastructure and its standards. Actually, the global scenario you can see in the graph. The current, despite of the difficult circumstances and the pandemics, negative impact on the automotive industry, electric vehicle made a giant leap forward in many countries in 2020. Actually, electric vehicle account for 4.2% of light electric vehicle sales in 2020, which is almost double. That is, in 2019, it's 2.5%. In 2020, it becomes 4.2% higher. Light electric vehicles sales are happened. And Norway is the highest EV selling happening country, and many more are in Iceland or Sweden are becoming in line with the Norway, and many countries are accepting the electric mobility as a future transportation. The EV sale trends in India is in the financial year 2020-2021 is shown in the graph. You can see that there is a steep hike in the February to March. There is it is observed that EV sales in March 2021 has steeply grown to 25,640 units from 18,768, and this is this figure gives the different vehicles EV sales. Pardon? Hello?
Ma'am, can you share presentation slides?
Yes, Mineeshma, ma'am, you can continue. You can continue.
My presentation is seeing, right?
Yeah, we can see it. We can see it, ma'am. You can see it. Please put it in slideshow mode. Or else you can continue in this form itself, ma'am. No problem. Yeah, now we can see it in slideshow form.
Okay. Here is the e-mobility tree, in which there is a lot of here is the EV innovation map for EV innovation map of our country. The EV components or EV components include motors, drives, and controllers, chargers, etc. The localized indigenous technology. We have to develop our own indigenous technology for the EV components and the charging stations. Also, the development of charging station should be done for done, and the maintenance, manufacturing, installation of the charging station. We have to look to frame policies to maintain the charging station and all, and the recycling, repairing, and retrofitment of EVs, battery and chargers. These we can see the EV tree bears the many fruits of opportunity. The figure depicts the technology innovation map of India, which includes the EV manufacturing components, charging stations, battery and chargers, and EV mobility. This will be the future efforts of EV adoption in India. So under these components, the rare earth magnet motors, that is permanent magnet motors, and battery technology for and thermal management system components, etc. We are trying for a perfect e-mobility ecosystem. We have to fulfill all these technologies within our country, and we will satisfy with these technologies in our country itself. There would be opportunities to invest some companies for establishing innovative business model for charging, recycling and retrofitment, etc. In view of this EV innovation map, we can say Government of India framed some policies framed some regulations or regulatory authorities to implement the e-mobility policy, and some Government of India initiatives are given, in which Department of Heavy Industries, which formulated the faster adoption of manufacturing of hybrid electric vehicles in India, that is FAME, and at first the development of hybrid and electric vehicles are targeted. After that, FAME 1 is from April 2015. FAME 1 is with a budget outlay of FAME 1 is established, and the many development programs are originated by this FAME 1. At CDAC, we also have one project with XCV real-time simulator for EV HEV simulation and development. We successfully completed the project, and some OEMs are requesting the technology transfer for this, and after that we are under FAME 2 is further to the FAME 1. FAME 2 is formulated to establish the different charging infrastructure in all over the country. The charging FAME 2 gives the incentives for EV owners and EV owners and exempted taxes for road taxes for EV owners. Under this FAME 2, the many incentives are given to the EV users, and Automotive Research Association India, which is coming under Department of Heavy Industries, has emerged some standards, AS 138 and AS 123, which is for the development of EV charging infrastructure and the electric vehicle retrofitment. AS 138 is the charging standard for electric vehicle conductive charging system for both DC and AC. The charging standards are published, and the overall charging development, its communication, its safety, and etc. are detailed, and these AS 138 is developed from some international standards like IEC 62196 and 123, etc., which comes the international standards which already developed in or already implemented in European countries. And Department of Science and Technology also initiating some programs on e-mobility. The Grand Challenge competition for EV charging system is the program they evolved for the development of indigenously developed EV components, or like electric motors, rare earth magnet motors, battery technology, etc. are targeted in this Grand Challenge competition. And DHI, DST together select one technology platform for electric mobility. They together work on the e-mobility mission and mission innovation in clean energy. This innovation is or innovation clean energy is the method or policy for formulating the or executing the development of fuel cell vehicles. Actually, the last union budget for set up a mission on hydrogen, National Green Hydrogen Mission, which aims to develop fuel cell and its technologies for the e-mobility and electric mobility transportation. And Ministry of Information and Electronics and Information Technology, MIT, our ministry, they also called for proposal for development of electric vehicle subsystem. We are submitting proposals through this platform, and we bagged some some projects on this platform, and we are under the process of this proposals. And NAMPET Phase 3. NAMPET Phase 3 is the National Mission on Power Electronics Technology, which CDAC Trivandrum is the, which is the CDAC Trivandrum acts as the nodal agency, and we are developing EV charging solutions under this NAMPET Phase 3 also. Other initiative that is for Ministry of Power with the Electric Energy Efficiency Service Limited together call for tenders and for setting up EV charging infrastructures with the specific standards and some Exicom, Embarrass Exicom, who won the tendering for tender for some EV infrastructure implementation in our country. The tendering process is going on. The process is it's not completed. It's going on early. Actually, government operative structure is government set up as agency, that is Niti Aayog, that is National Institution of Transforming India, to acts as the implementing agency, which coordinates the various ministries, that the Ministry of Power, Ministry of Road Transport and Highways, Ministry of Urban Development, and Department of Heavy Industries. They together work for the e-mobility mission, and Niti Aayog is the implementing agency for the Government of India. So it's Niti Aayog acts as the bridging between PM office and the different ministries and in our country. The Ministry of Heavy Industries, Ministry of Power, Ministry of Urban Development, Ministry of Finance, Ministry of Heavy Industries set up the standards for the EV charging infrastructure. The draft the standards has been published now, and Ministry of Power and Renewable Energy, with the help of the public sector units like NTPC and all, they are also into electric mobility mission. The Ministry of Urban Development with the Niti Aayog also under the Smart City program, they are also setting EV charging infrastructure with the specification standards. The Department of Science and Technology, as I already told, some technology platform for setting up some grand challenge or platform for OEMs or stakeholders to come into the e-mobility activities. So Government of Kerala also having some initiative. Kerala e-mobility policy is developed, and there is a target of mission of full electrification of all type of motor vehicles is by 2030. 1 million of EVs. That is the e-mobility policy says we can target for 1 million EVs by 2022. And there is we are set up, Government of Kerala is aims to set up some charging station and swapping stations initially in Trivandrum, Ernakulam and Kozhikode, and some EV incentives are given under the FAME 2. Incentives are for EV purchases given for EV users who are purchasing EV, and exemption from road taxes are also given. These are the Government of Kerala initiatives. And e-mobility plans by states also the different states almost the main states, that Andhra Pradesh, Karnataka, Maharashtra, Telangana, Kerala, Uttar Pradesh, Delhi, etc. sets e-mobility mission plans, and they set up their own e-mobility plans with respect to the Government of India initiatives, and different plans are working out. And in Andhra, some 1 lakh e two-wheelers, electric vehicle two-wheelers are purchasing for their staffs for accelerating the EV electric vehicle usage. And in Karnataka also, e-mobility with the renewable energy integration is promoting all, and almost all the states in our country is setting up with the e-mobility plans. And in Kerala e-mobility mission, there is a charging station implemented at Secretariat. It's owned by Delta Chargers, and the associated with KSEB, Kerala State Electricity Board. The charging station implemented is of Delta Electronics. Delta's charger is implemented at the Secretariat of Kerala Secretariat. So the components of e-mobility market, actually e-mobility ecosystem includes electric vehicle, charging infrastructure, and the supply chain. So when we targeting for an e-mobility ecosystem, when we are targeting for a electric vehicle only electric vehicle transportation will be there with when for the 2030 mission. EV 30 at 30 campaigning is happening all over the world, and we for making our view or ambition, the target, making success to our or making our policies become policy is to be success. We have to implement these setup for these 3 components should be there. That electric vehicle is the main thing in which in India the vehicle the 80% of vehicle is of two-wheeler and three-wheelers, in which three-wheeler rickshaws are more and more, and the passenger vehicle, passenger car and passenger buses also there in a smaller percentage. So we have to set up charging infrastructure for these the lower end vehicles, that is light electric vehicles, and with the definite charging infrastructure standards. And supply chain means even electric vehicle and charging infrastructure is set up, we have to set regulations for these regulations and policies for the payment or the implementation or running of the vehicle or infrastructure, charging infrastructure. So the under the e-mobility market, when we have to implement all these things, we can set up a perfect e-mobility ecosystem. EVSC or electric vehicle supply equipment, which is the from the name itself, we can say that it is the supply equipment which supply the electricity to the vehicle. It supply the electricity to the vehicle. It is of actually we can under the EVSC can but technology basis and charging basis and end user basis, we can differentiate the EVSC. In the technology basis, it's on whether it is onboard or offboard, AC or DC, and conductive under in the about it's under the charging type, we can say conductive, inductive, or swapping type of EVSC. And end user type, it's or public or private. So onboard or offboard type of charging means, I can say in the next slide actually. So I will briefly explain. The onboard or offboard means onboard charger or charging supply equipment means manufacturer itself will give a charger. When charging equipment will be there in the vehicle itself, we have to provide supply to that charger. And EV battery which should be supplied with the DC voltage, and we can provide the onboard charger which converts that AC converts the AC supply to the DC and given to the onboard. In the onboard charger is the thing which convert AC to DC. And offboard charger means the charger is in the which is outside the vehicle, which is not inside the vehicle, and we have to provide a DC from outside to the EV battery. According to this, we can say the AC slow charging under DC fast charging is there for AC slow charging takes place approximately 7 to 8 hours, and DC fast chargers may take 45 minutes to full charge. And according to charging type, there is we can say the EV supply equipments are of conductive, inductive, and swapping type. Actually, conductive method means it's the charging is done by using conductive mechanism, that is charging cables. When we are giving supply or to the battery through a conductive material, that is that's what mean by conductive charging type EVSC. And inductive means we are transferring the electricity by means of a electromagnetic field which is given to the vehicle, and we can given to the battery also. And swapping is the technology where EV owners can exchange their discharged battery to the swapping station, and he can take the fully charged batteries to actually the swapping of battery is happening, and the need of the hour, maybe we can say that the next technology for the future may be swapping, and we can remove the charging time. Actually, the conductive charging requires more charging, as in the case of a slow charger. So when we are using swapping technology, we can instantly swap the battery, and when we are refueling our IC engine in a petrol bunk, we can mimic the swapping station like that, and we can save the time, and we can the range anxiety can be reduced, or the capital upfront cost of battery can be reduced. Actually, in India, from 2020 August, the government is allowed to sell our electric vehicles without batteries. Without battery, we can sell, or the manufacturers can sell EVs. So the swapping station is a technology for the future, and the swapping stations are coming out in the country, and it's a developing area. And end user, according to end user, Avsc can be divided as public and private charger, private equipment, private Avsc and public Avsc. Public Avsc means it can set up at hotels, malls, or cinema theaters like that. We can set up Avsc. One can provide charging infrastructure as a service to the and charging station provider can manage the charging, and by use of time, energy, or time used for the charging, or energy used, or money, what type which he can use the public charging station. Private charging station means when we are using our charging, when we are doing charging at our home, at our home premises. When our EV is charging at home slowly by using a AC slow charging mechanism, the charging EV supply equipment is known as private equipment, private EVSC. So AC or DC conductive charging, we can say that here the vehicle is having an onboard charger and a BMS, battery management system. Every vehicle has an onboard charger for AC charging. It has a limited power only, and its charging is very slow. The onboard charger is giving power to the battery. If in the case of a DC fast charging station, it's DC conductive charging, by the charging cable is connected to the vehicle, and the infrastructure investment is shared among hundreds of users. That is, public charging infrastructure investment can be shared, shall be shared among the users of the charging station. Its power rating is usually large, and we can target for a fast charging also. It is capable of renewable energy integration. When we are taking power from grid, when all our charging infrastructure is installed, and when our grid is not capable of or is not if there is lot of impact to the grid when we are installing a lot of our charging stations all over the country. Our grid should be capable of balance the power to the charging station and the power to our nation also. So a solar energy type charging station or renewable energy charging station, integrated charging station should be targeted for the uh, large installations or for high power installations. Here is the inductive type of charging. Actually, charging conductor will be laying on the road, and vehicle has its own inductive pickup setup is there, and we can in the platform the charging conductor create a electromagnetic field, and in inductive pickup will take that, and energy transfer will be happen, and it will be given to an AC to DC rectifier and energy management system, and we can given that will be given to that charge to charging the battery. The charging conductor is powered from the electric grid also. Actually, inductive charging is not not that much developed in our country. Will generate or will flourish more on this will happen in near future. We hope so. The different electric vehicle in our country, that is we have EV. When we are using EV, there is a major factor of EV hindrance to adopting the EV use. That is the range anxiety. For a full charge battery, Mahindra E-Verito, Tata Tigor, and etc. Also Tata Tiago, etc. Give only 100 kilometer, and Tesla Model S, that is it's a technology, highly efficient technology, which gives 370 miles, and e-rickshaws are targeted to 15 to 25 kilometer, and e-auto rickshaws are 58 to 80 kilometers. Here comes importance of battery swapping. When we are using electric scooters and e-auto rickshaws, only 25 kilometer ranges range will be provided by a battery. So again charging that battery again charging that battery, and for the usage, the profit of rickshaw drivers will be very much low, and that is not possible also. So we can have to or swap the battery will be the technology of battery swapping will be good for each electric vehicle, electric scooters, and e-auto rickshaws. So here is the need of charging infrastructure in a single format. That is, we have to fill up our e-mobility mission to full or top up charging needs. We need e-mobility charging needs. The EV charging infrastructure should be implemented, and the range anxiety also. And for smooth EV fleet operations, the charging infrastructure at workplace or public places like malls and hotels, we have to implement a charging infrastructure. And to match the ratio between EV introduction to public charging infrastructure expansion, also we have to implement more and more EV charging infrastructure in the near future. So in India, actually 75% of vehicles are two-wheelers, 6 to 7% vehicles are auto rickshaws, and 30 to 15% vehicles are cars. So, and there is one standard, that is AS 123, in which is the conversion of electric is expected immediately in two-wheeler and three-wheeler and four-wheeler to the retrofitment of electric vehicle. That is so and electric cars are becoming more popular in factories, hotels, resorts, and gated institutions like IITs and IICs, and airports, railway stations, bus stations, hospitals, etc. Electric forklifts are essential in all shift of the factory. So, we in India, these much of EV. These much of EV Avsc requirements are we have to fulfill all these requirements. And so technology for as a technology forecast, we can say that Energy Efficiency Service Limited, there is 2,000 charging stations are required, and rail, they are expecting 270 charging stations. NTPC, Global, and Bell, ESL, ITA, etc. These are the agencies which are implementing charging stations. So, and these are some of the players current EVSC manufacturing, that is Exicom Power Solutions, Tata, Delta Electronics India, RRT Electric Power, Enarca, Master Controls, SBD Green Energy. These are the some current players in EVSC manufacturing. Actually, there are more and more. Most of the installations are imported. Here comes the importance of the indigenous solutions and cost-effective ones with better maintenance. So, EVSC Indian requirements are should have AC slow chargers and 15 kilowatt DC dual point chargers, 50 kilowatt DC fast chargers, 150 to 350 kilowatt DC fast charger charging from renewable sources. These are the Indian requirements. Requirements to satisfy the electric vehicle users. This is the requirements are requested or given in the AS standard. Actually, automotive industry standard 138 is published by ARI, and from that AS 130 standard, a specification document, that is Bharat EV charging document, also published, and under this these requirements are given. And in CDAC, under NAMPAT, we are developing these AC slot charger, 15 and 50 kilowatt DC charger as an indigenous technology. Next, I will explain the standards in EVSC. Actually, AS 138 standards standard is the standard which we are now following in our country, and Bureau of Indian Standard BIS also working in a standard for EV charging infrastructure associated with this AS138 standard. And AS138 standard is developed from many international standards. It's formulated from many international standards such as IEC 61851, and that is the general requirements of EV charging, conductive charging requirements. Is plugs and the standard for plugs and sockets, that is IEC 62196, 1123, etc. For communication, the charging standard is ISO IEC 15118. In a safety aspect also, the international standard is taken for the reference, that is IEC 60529 and IEC 60364. These are the standards which are used or referenced for the development of AS138 standard. So EVSE in the AS138 standard, they are actually they are explaining about or given the specification requirements of AC charging station. That is part 1 is AS138. Part 1 is given for a conductive charging of electric vehicle, conductive charging for AC system, AC charging. And in that we can say the charging connector is of the standard, should follow the standard SAE J1772. And the part 2, IAS 138 part 2 is published and it is the conductive charging of DC conductive charging for DC systems. That the DC fast charging is happening or DC fast charging requirements are given in AS 138 part 2. In that the connectors or charging connectors or cable standards are also given. The 3 charging standard or connector for interface for EV charging is given as CHAdeMO, GB-T and CCS. Actually, CHAdeMO is the international standard followed in Japan, and GB-T is followed in China. CCS is followed by European countries. Actually, these 4 connectors or interfaces are used to communicate or connect the EVSC and the electric vehicle, EV and EVSC, to charge the vehicle. SAE J1772 is the charging standard for AC charging. There is a control pilot pulse. Control pilot is there in the SAE J172 connector, which is whose pulse width is determined to the control pilot is controlling the power to the EVSC and create an identical control panel signal to command the vehicle to reduce maximum charging power, and the battery management system adjusts the charge rate in response of the battery management system is adjusting the control pilot adjusting the charge rate in response to the control pilot signal. And once again, the EVSC delivers the electrical energy from an electricity source to the charge electric vehicles energy storage. EVSC provides the alternating current AC or the direct current supplied to the electric vehicle that is needed to charge the vehicle's traction batteries. EVSC communicates with EV to ensure the appropriate and safe flow of electricity supply. The communication is the different communication standards are followed in different charging type. In electric vehicle equipments, we can say there is AC charger and DC charger, and there is a combined charging system also. In type 1 AC, type 2 AC charger is there. Among these, the current rating of charging rating, maximum current rating is different, and according to that, the charging cable charging communication standard or charging standard is also different in type 1 and type 2. CHAdeMO and GB-BARTI is the DC charging and charging standards, in which GB-BARTI is having a CAN communication between EVSC and the EV, and CHAdeMO also having a CAN communication layer between EVSC and the BMS of EV. And combined charging system is the is in which we can use both the charging current, that AC and DC charging current can be done using CCS combined charging system, in which CCS1 and CCS2 the communication standard is the power line communication. PLC communication is running between the vehicle and the EVSC. This is the AC charger type. Type 1, that is Avsc SAEJ 1772, that is the charging cable standard, and the charging inlet standard. It's followed in Japan and accepted by USA. It's up to 7.4 kilowatt, that is up to 32 amps. Type 1 we can use. Many OEMs which are using AC charger, that is Nissan Leaf, Nissan ENV200, Mitsubishi Outlander, IMU, Peugeot, etc. are using this type 1 connector. Type 2, it's up to 44 kilowatt, 63 amps, 3-phase 63 amps is the type 2 connector. In BMW, Audi and e-tron, the charging connector and cable is of type 2. And CHAdeMO is the origin from Japan and in most popular DC charger in the world. It's used in Japan, Korea, and parts of USA and Europe. Nissan Leaf and Mitsubishi has CHAdeMO connectors up to 400 kilowatt DC charging, 1000 volt to 400 amps. 400 amps can be done using this CHAdeMO standard charger. Communication between EV and EVSC is control area network, that is CAN communication. GB-BARTI origin from China, China as well as Bharat chargers in India, Chinese vehicles, and Mahindra Electric in India. Up to 23.75 kilowatt, that is 950 volt to 250 amps. That is the maximum rating. Here also the communication is between EV and EVSC is via CAN. These are the standards of specified in the GB-BARTI is the in which communication protocol is SAEJ 193911 and 193921. The application layer refers to GB-BARTI's 27930. The charge control communications physical layer comply with ISO IEC 151183. These are the communication protocols which are referenced in the AS 138 standard. So we have to implement these protocol for GB bar T or CHAdeMO compliant DC fast chargers. EVSC charging and communication process. So EVSC is communicated with the user. EVSC has to communicate with EV, and EVSC has to communicate with a CMS, that is central management system, in which the different EVSC service providers can communicate with this CMS for the allocation or saving of electricity, charging bills, etc. So EVSC communication is of this type. So the communication between the EVSC and the central management system is via a open charge point protocol, that is OCPP. It's an open protocol to enable advancements. In most of the countries, the manufacturers are part of this. So CMS is the charging station. When charging station directly connected to the central management system, we can use this OCPP and local and local controller can connect the multiple charging station also. That is CMS via OCPP connected to a local controller can be connected via different connected to different charging interconnected charging station, and operation can be done using this CMS protocol. For mobile applications development, that EV users can using mobile applications, EV user can identify how much amount of charge is there within his battery, and where is the charging station can be located, and the charging history, etc. He can able to visualize. This is the EV users can use these technologies. So Bharat EV charging specific from, I already told you that the AS 138 by Department of Heavy Industries is formulated, and the different EV charging specification, the charging specification for the country is formulated from that AS 138 is Bharat EV charging specification, that is Bharat EV charger AC001. It's a 3.3 kilowatt AC slow charger, and it's the voltage and current rating is 230 volt and 15 amps, and it has three independent charging, should have in three independent charging sockets as per IEC 60309, and as per the AS 138, the protection requirements should be satisfied. Metering as per units consumed for charging the battery of each vehicle as per Indian standards. So the in Bharat EV charging specification, the two type of DC charger should is specified. That is, type 1 is connector should be GB bar T compliant, and power rating should be 15 kilowatt, and rated voltage may be 48 volt and 72 volt. The number of charging point or guns must be 1 or 2. There is another requirement, that is connector may be CCS or CHAdeMO, power rating should be 50 kilowatt and rated voltage is 1000 volt maximum, and number of charging point is one for CCS and one for CHAdeMO. So in view of these charger requirements in our country, CDAC is developing some dual point charger, 15 kilowatt DC dual point charger for addressing the requirement specified in AS 138 and the Bharat EV DC 001. In that we are having a 3-phase 5-wire system that there is an active front end converter which which act as a rectifier, and the corresponding AC is converted to DC, and there is a regulated DC bus is there, and we are giving this to a DC to DC converter. We are using a phase shifted full bridge type of technology for DC to DC conversion, and charging interlocks and communication lines. As you already know that the communication is via a CAN and the GB/T 20234.3 standard connectors are given in the 15 kilowatt DC dual point charger, and DSP based controllers are there, sensing and protection circuit, gate driver circuits, and Avsc communication and user interface circuit, etc. are the this is the entire block diagram of the 15 kilowatt DC dual point charger. Here is our next development. This is 3.3 kilowatt solar photovoltaic DC charger, in which developing a 3.3 kilowatt charger. There is a DC to DC converter from and a bidirectional AC to DC converter from grid supply also. The integration of renewable energy or solar photovoltaic integration is targeted, and we are in the testing level of this proto model, and the phase shifted full bridge DC-DC converter is used to convert DC to DC, and also here also the digital signal controller is there, and communication interface, EVSC communication and user interface also is there. This technology we are targeting to integrate this charging technology with the solar photovoltaic technology. There is here is our next development, that is 50 kilowatt DC fast charger. Here also a 3-phase 5-wire system with the active front end converter and a isolated full bridge converter, and here the charging cable is CHAdeMO or CCS, and the communication is via CAN and PLC. Communication and user interface is given, and here we are doing actually this is the first level of the drawing, and we are now we are developing 25 kilowatt module of DC fast charger, and two 25 kilowatt system consists of total of 50 kilowatt DC fast charger is using, and we are using a series parallel unit parallel interchanging unit which you use to convert usage of 50 kilowatt or 25 kilowatt. Here also CHAdeMO has CAN communication and CCS has PLC communication. This is the AC charger technology which we are developed, and it's demonstrated in our campus also, and we are developed under this. We also developed. This is a technology where three-phase AC is given. Is given as input, and we are taking three single port output for AC charging. Here the main development is under this area, that is there is a protection and safety interlocks or safety circuits for the AC charging system, a communication system that is OCPP compliant interface, that is communication between CMS is done using this block, and there is RFID mode of billing and payment, metering, etc. Metering, billing, payment, etc. We are implemented. Here the user interface and display, etc. Requires these type of displays, that authorization status, error status, charging duration, presence of input supply, etc. These are the requirements from AS 130 standard and Bharat EV charging specification. We are developing these technologies under from the data from the data or requirements from the AS 138 standard. And one single port charger. Here we are using three-phase AC and one single phase, single phase ACs. The single phase AC charger also we are developed, and now the mighty electronics Ministry of Electronics and Communication Technology, that at Electronics Niketan Delhi, we exhibited or implemented one of our technology last week, and it's inaugurated by our principal secretary. Is the proposed model of EV charging station. Actually, we are exhibiting. We are the technology developed EV charging infrastructure or e-mobility. We are developing the charging of 3.3 kilowatt AC charger, 3.3 kilowatt SPV DC charger, 15 kilowatt DC charger, and 50 kilowatt DC charger, and a renewable energy integration also targeted. These four technologies shall be demonstrated at our Technopark campus at CDAC Trivandrum. The technology is in progress. The technology development is in progress. Many of the activities are completed. Some of the testing activities are in progress. So, as a status summary, I can say that electric vehicle EV 3830 campaign, as that a government is implementing or initiating a lot of EV acceleration or electric vehicle adoption in our country, and by 2030 we are expecting 30% of electric vehicles will be electric. And Ministry of Target in the latest Niti Aayog EV charging infrastructure handbook says that at least one charging station should be available in a grid of 3 kilometer versus 3 kilometer, and one charging station should be set up every 25 kilometer on both sides of highways and roads. This is the target of Niti Aayog. So the technology is developing, and from the indigenous technology, we have to work together for the different OEMs and industry collaborations and R&D labs like us. We have to reach the goal. And from August 2020 onwards, and I already say that the Ministry of Road Transport and Highways allowed to sell electric two-wheelers and three-wheelers without battery packs. So EV charging can be done using battery swapping station. or recharging can be done using within 2 to 3 minutes. The range anxiety and the capital upfront cost of EV can be reduced by using the or implementing the battery swapping swapping stations. So, under the in view of the above, we are developing WPG-based electric vehicle supply equipment for charging station by CDAC Trivandrum under phase 3. So, here is the link for the EV technology which we are developed at and demonstrated at MIT campus.
Electric vehicles or EVs are becoming the new standard for mobility all over the world. Implementation of electric vehicle transportation depends largely on charging infrastructure, named Electric Vehicle Supply Equipment (EVSE), for full or top-up charging needs. One of the key roadblocks is the lack of charging infrastructure and upfront cost. The system requirements of different EV users may vary depending on the charger types like AC, DC, public, private, etc. CDAC, a scientific society under the Ministry of Electronics and Information Technology, focus on indigenous development of systems and products. Our electronics group of CDAC Thiruvananthapuram has been keen in framing a roadmap to develop EV charging solutions with AC electric vehicle supply equipment as the first product. The 3-port AC charger has 3.3 kilowatt charging points enabling simultaneous charging of 3 EVs. Indigenously designed and developed charger has all protection schemes under AIS 138 standard and meets the Bharat EVC AC001 specification. Networked and standalone AC charger models are available for implementation. Standalone charging stations are designed for known local user groups who repeatedly use the same charging station. These charging stations keep a localized database of registered users. Authorization is done using radio frequency identification (RFID) and the local whitelist. This is an economic option as the user need not have a smartphone and only requires an RFID card which costs less than 10 rupees. The EVSE user interface and communication application or EVSE CUI provides a user interface for the customer to input his charging preferences like time, energy or cost-based charging. Metering and billing information for user are also updated in the GUI. An emergency stop option is also provided to the user. Other features include display of fault messages like connector unplug, over temperature, over current, over voltage and under voltage. The user is given a provision to stop charging in between the charging progress. Authorization, metering and fault management is handled by a real-time application or RTA running in the EVSE. Usage data of each customer is stored in a local database and bills are generated periodically. Network charging stations refer to multiple EVSEs controlled by a central monitoring system named Central Management System (CMS). CDAC has developed a complete network charging solution comprising of the Avsc, CMS web portal and Android mobile application. RTA and Avsc CUI applications are installed within the Avsc, having high-performance microprocessor boards capable of handling real-time application, GUI and web server application. The system consists of interactions between EV user, Avsc, mobile application and CMS. Open Charge Point Protocol (OCPP) is the industry-supported protocol used for communication between the network charging stations and CMS. CDAC chargers uses OCPP for Avsc CMS communications to ensure interoperability among different vendors. Since EV users need to access multiple Avscs at different locations, the Android mobile application supports searching and locating charging stations, user authentication, charging history review, vehicle data management, real-time charging status monitoring, billing and payment for usage. CMS, the web server application for charging infrastructure administrator, centrally manages and monitors the Avsc's, EV users and charging sessions. CMS can monitor registered users, their vehicles, charging history and transaction history. Using the CMS, admin can configure charging stations parameters such as connector type, rated power, etc. and add new charging stations. Active sessions of charging can be monitored in real time by the admin. CMS is capable of implementing demand-based tariffing and charging sessions will be built accordingly. Functionalities which need high-speed computing like metering and fault management are performed by a separate real-time application to improve the system performance. Presenting the complete system process flow in a network charging station. The process begins with user authentication by scanning Avsc QR code at the Avsc using mobile application. After successful user authentication, he enters his charging preferences like energy or cost in his mobile application. These details are sent to the CMS. Payment estimation is done based on the current tariff and amount payable is sent to the EV user's mobile from CMS. UPI payment is made and payment status is updated to user. On successful payment, an OTP or token will be generated and sent to mobile by CMS. User enters the OTP in the user interface at Avsc. This OTP is sent to the CMS for authentication. Avsc is replied with an authentication status from CMS. Upon receiving the authentication status, user is prompted with a screen showing authorized units of energy or amount to charge and a start charging option. User clicks on start charging to begin the charging process. Once the charging is initiated, the charging status is updated to CMS from Avsc periodically. User can review the same using mobile application. On completion of charging, status will be updated to CMS and CMS sends the same to user's mobile. User has option to stop charging in between the ongoing charging process. Other fault conditions are also updated from Avsc to CMS. Emergency stop option is also provided to the user. The public metered AC outlet is compatible with all electric vehicles having a C-slow charging interface. The charger is provided with an IEC 60309 industrial socket as per Bharat AC 001 charger specification and a 16 ampere 3-pin residential type socket. The EV owner can use the adapter cable supplied along with the vehicle for connecting EV to Avsc. The driver uses his ID card for authentication. Here, charging of a 3-wheeler EV is being performed by single-phase 3.3 kW AC charger. Usage data for each user is stored in the charger and bills are generated periodically. CDAC single-port and 3-port AC chargers are the initial milestones towards indigenous and cost-effective solutions for expanding EV charging infrastructure in India. Project is funded through National Mission on Power Electronics Technology, NAMPATE Phase 3 program.
In listen-only mode.
Hello everyone, I am Rahul Bagadia and shall be moderator for today's webinar. I am co-founder and director at eManifold. I welcome our speakers, Dr. Ajit Jindal, Head Technology Vice President.
All the participants are requested to wait. I think there has happened some technical error from Mineeshma ma'am. Hope she will join soon. Yes, Mineeshma, ma'am. Am I audible for all? If participants are having any queries, you can ask queries to Mineeshma, ma'am, now. Mineeshma, many participants are asking that whether you will be sharing the slide with us.
That's okay. I can share.
Okay, fine. If any participants are having any queries, please ask. Or else we can move to the feedback session. Fine. I request any one of the participants to come and give a feedback to Mineeshma, ma'am, regarding the session. Dr. Soni, ma'am.
Yes, sir.
Ma'am, can you please give a feedback to Mineeshma, ma'am?
Yes, sir. The session, ma'am, the session was very informative. The way you have given the elaboration of explanation, and you had also shown the videos to us, which made us to understand properly the different types of charging systems, what you have explained. Thank you very much for your session, ma'am.
Thank you, Soni, ma'am. In fact, I feel very proud seeing that our country has developed such a fully charger, that is AC charger for this electric vehicles. In fact, all of us must be aware that such an R&D organization is there who is establishing and developing such sort of items in our country. Now I am moving to vote of thanks for Mineeshma, ma'am. Thank you, Mineeshma, ma'am, for taking the time out of your busy schedule to share your knowledge with us. You have distinctly demonstrated the various government schemes, the scheme of electric vehicle supply equipment, swapping technology, conductive charging, inductive charging, various standards, and the technical video shared by you were also very informative. On behalf of all the participants and College of Engineering Talashiri, I express my wholehearted thanks to you for being with us for the session. Thank you, ma'am.
Thank you.
Yes, we are dispersing for now, and we will be having the lunch break, and we will resume at 2 o'clock. Requesting all the participants to join back using the same link at 2 p.m. Thank you.
Okay, sir. Thank you.
Okay, then. Thank you, Mineeshma. Bye. Recording.